So we're back to ACDC room, and let me present the next speaker. It's Josh Long. I talked with him a few days ago. Hi, Josh. Can you hear me?
I can. Can you hear me?
Yeah. Can you hear you well? Where are you saying? Where are you saying hi from? I can see it's dark outside.
It is. I'm in San Francisco, California, in the United States.
Okay. So it's now past midnight, I guess.
Oh yeah, it's past 1 actually.
Okay, so a late night session with Josh Long is awaiting for you. So Josh is the first Spring developer advocate since 2010. He's a Java champion. He's an author of 6 books and numerous best-selling video trainings. He's an open source contributor, a podcaster, and a YouTuber. I was watching some of your YouTube comments, YouTube videos, and they had all great comments complimenting your joke skills in IT topics. So let me present you, Josh Long. Josh, take it away. And as always, the questions are welcomed in the chat. I'll be back to ask you the questions after the session. So Josh Long, everyone.
All right, good. Thank you so much. Let me share my screen. Oh, it's already shared. Good stuff. I appreciate this. I appreciate you all being here. Good morning, good afternoon to anybody and everybody who's watching all around the world. I appreciate you being here. My name is Josh Long. I work on the Spring team. I am, as he's just said, a Spring developer advocate, a Kotlin Google developer expert, and a Java champion. And I'm at your service. And so you can see on this slide, arguably the most important slide that you're going to see today in this room, in this hour. On the slide, you see my coordinates. So should you have questions, comments, whatever, don't hesitate to reach out to me. You can reach me on Twitter at StarbucksMan, or my direct messages are wide open, or you can reach me on email, right? So I'm happy to engage there as well. And there's also my Git repository that contains everything that we're going to look at in the next 45 minutes or so. Okay, so a lot of stuff there. Just take the photo for later, a screenshot, whatever, and we'll refer back to it later on. Okay. I work on the Spring team. I've got videos. I've got a book. I've got a podcast, a screencast, actually, blog, screencast, and a new book called Reactive Spring. And that really, the book is the long form version of some of the stuff that we're going to talk about today. Reactive programming, and in order to really appreciate what we're going to talk about here, in order to really appreciate reactive programming, let's consider the larger context, the larger picture. What do we care about, right? I care about getting software into production. And so a natural goal is to move quickly and get software into production, to take an idea from concept all the way to customer, right? This is the large picture, the big picture that's always with me when I try and evaluate a new technology. And so when I start thinking about this, obviously, it's very natural. In the last 15, 20 years, we start thinking about, okay, I want to optimize the process so that I learn quickly, so that I can make changes in response to what I learn quickly. So I have an agile turnaround, right? I have the ability to iterate very quickly, to grow my software very quickly. And so one of the things that you see people who are trying to optimize for agility is they move to microservices, right? Microservices allow teams to be small. It allows them to reduce the lead time or the inventory that it stacks up at each person's desk. It's just a generally very nice way to allow an organization to go faster, to allow different teams in an organization to go faster. It's the reverse Conway maneuver, right? We're optimizing our organization so that our software gets better, right? And so this is all very natural, very understandable, big picture stuff. But what happens when you start moving to microservices? What are some of the things that you think of, that you start running into? First of all, we're doing a lot of communication over the network, right? A lot of communication over the network. And so suddenly our services, our applications, our monoliths, which were mostly, CPU bound before, they're mostly doing work inside the JVM, are now mostly IO bound, right? There's lots and lots of data being conducted over the network. So suddenly, the old ways where we started to do input and output, suddenly those don't work so well, right? Suddenly Java IO input stream and output stream are not our friends, right? If you look at Java IO input stream, it gives us a very simple API. We say input stream.read, and we ask for the next few bytes in the thread, and we get a result, but we have to wait. So when we're sitting there in a thread, just waiting for the next bytes. Come on, bytes, where are you? And these bytes we'll eventually get there. But in the meantime, we're stuck on a thread, unable to use that thread for something else in the system. And this is a massive throttling point for our service, because if you look at a lot of services today, especially those written with traditional blocking input and output, you'll find that they're idle. The CPU is idle. And yet, sometimes they won't be able to accept new requests. It's the weirdest thing I've ever seen. You log into a service and you can't make any more requests to that service because every thread parked in the thread pool is blocked. It's waiting for something to happen. And yet the CPU is empty. And this is, by the way, just a tangent. This is a great reason why it's nice to have your container platform like Kubernetes or Cloud Foundry or Docker Swarm or whatever. It's nice to have a container platform that will tell you the relative memory use and CPU use and RAM use and whatever of your containers. But that is never the full story, right? Because think about what I just said. Imagine a scenario where you have a container where you have very little CPU activity, it's idle, and yet you have no ability to respond to traffic. You're dead in the water, right? You're not able to move forward at all. This is an example where the numbers lie to you, and you need to have application-specific metrics that tell you whether your service is healthy or not, because just checking CPU doesn't tell you much of a story. Anyway, so we've got this service there, and it's waiting for something to happen, waiting for bytes to happen, and nobody's getting responses. This is a problem. So we need some way to rework the way we write code so that we can avoid these blocking interactions. And it turns out that input and output is a huge, huge category of things that we can avoid that do blocking interactions that require us to waste time on these threads. If we're willing to change our code a little bit, we can rework it so that we can avoid blocking our APIs. This gives us the ability to reuse those threads for lots of other work. We get better scalability. Okay, so we move to microservices. Then what? Well, of course, now let's say that we've made each service as robust and safe and we've made each service as scalable as possible. But now we have the inherently risky network, right? The network itself is failure prone. There's lots of errors that are possible there. And so what we need now is a programming model that allows us to describe, first of all, data that could be, very small, or data that could be very large, right? Unbounded, or asynchronous, or latent, right? It takes time. So that new world, we don't have good abstractions for describing that kind of data, latent or potentially unbounded data, right? That's the next thing that starts to become obvious, is we don't have a great way to communicate that data across the wire efficiently. The next thing that becomes obvious is we are dealing with this crazy faulty network, right? And so this network could fail, right? As you scale your organization, statistically, something is going to break. Large organizations like Google and like Netflix and so on have not had one day in years where some service, some computer, some hard disk, something somewhere in their organization was not broken, right? Every day, something is broken. Every time, every hour, every second, somewhere in the world, there is a computer that is not doing what it should do in a data center in Google, right? They've never had a moment where that was not true, or it's been years since they've had a moment where that was not true. That's okay, right? These organizations have written software understanding the reality of failure. They understand that things will fail. They don't care. They've embraced that reality and written software to be more resilient, more robust. And so this is another thing where reactive programming gives us a leg up. It gives us a nice way to write resource efficient, scalable code. It gives us a nice consistency, which allows us to move quickly and to make short work of the integration of different things. It also gives us a API to build software that is aware of the volatility of the network. So all these things are very desirable. Now that we've kind of understood how we got here and why we care, right? We're doing microservices. We care about building services on the network, and we want to get past some of these different limitations that become obvious when you start to scale out your services on the network. Now that we understand all that, let's talk about Spring. Okay. Now I love Spring. I think Spring is a fabulous way to build software intended for production, but you don't have to take my word for it, right? There's lots of small, mom and pop shops out there, right? Little organizations that have been using Spring with great success for years. Organizations like Netflix and eBay and Alibaba, right? These are organizations that use Spring everywhere for their services at scale, right? Handling Alibaba, what is that? Billions of requests on 11, right? That's, oh, by the way, wasn't that 2 days ago? I haven't even checked what the numbers are this year. I wonder what they are. They're always so crazy, and that's all Spring every year. All that stuff is Spring. So I know it can be done, but I want to make it as easy as possible, right? So here we're going to use Spring. We're going to use Spring Boot. We're going to go here and we're going to build some new software, and we're going to start our journey to production here at start.spring.io. Now, obviously, I love production. Production is my first favorite place on the internet. It's the best. It's the happiest place on earth. It is better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. Now, today we're going to build a new application. We're going to use the reactive web support. We're going to use R2DBC. We're going to use Lombok. We're going to use RSocket, and we're going to use Spring Security. Now, this will give me a number of different dependencies, and I can use them. I'm happy to use them, right? But we do have some more things to configure. We want to configure, first of all, what the name of the service should be. So I'm going to call it service, all right? And then we want to configure the choices down here that we're given. Now, friends, we have two choices here, the choices of packaging, and people struggle with this. They don't know when to choose which option. So let me explain. Obviously, it's 2020, nay, almost 2021. So you should be using jar, right? Don't use .war. This is a big part of my overarching and guiding personal philosophy of make jar, not war. And again, lots of different options, lots of things you can choose, but I encourage you to stick with the defaults. Now, that's one thing. The other thing that we have to care about is the choice of the version of Java. Now, friends, we have before us 3 checkboxes, 3 radio dials, but really we've only got 2 choices. You see, Java 8 is a non-choice, and that's not just an Indian bread, my friends. That's a thing that you could select, but that you should never, ever select. It's a terrible idea to be using Java 8 in 2020, nay, almost 2021. Java 8 is technically inferior. It has less syntax, less performance, less robustness, less security. It's also morally inferior. Do you think that your kids are going to be happy to find that you're still using Java 8 in production? I don't think they are, friends. I don't think you're ready for that conversation. No. We need to make sure that we use at least Java 11, which is the current long-term supported version of Java, or we use Java 15, which is the current supported version of Java. Both are valid choices. I won't judge you too much if you choose 11, but definitely don't choose Java 8, okay? Now I'm going to choose Java 11. Let me just make sure that that's the default for me right now. Java 11, okay? So SDK list, and we'll switch over Java. I got to make sure I get the most out of my installations here. SDK default Java, all right? There we go. So we're going to hit Java 15, and I'm satisfied with my selections otherwise, except I want to bring in the SQL database here as well. So Postgres, okay? There we go. So I brought in Postgres, Spring Security, RSocket, Lombok, the reactive web support, and more on. Now, let's see here. We're going to build the service. We're going to edit the service. We're going to develop the service in my IDE. It doesn't all that much matter what IDE you use, so long as you use something that supports Maven and or Java 15, right? Now, this new release, the release that, no problem. This new release, Java Spring Boot 2.4, which just came out today, that version is brand new. It just came out today. That's all for you. Well, there's some other people that will benefit too, but basically we did it for you, right? So Spring Boot 2.4 came out today, and it has a lot of really cool features, including native support for reading config maps that have been mounted as config trees in Kubernetes. It's got the same old great support for building Docker images out of the box, but now you can also build native images using GraalVM. It's got, just lots of cool stuff. So I hope you'll check it out. It now supports Java 15, for example. So all that stuff we get out of the box here. Now, I'm going to build a new service, and this service is going to, well, first of all, we're going to need to take away some dependencies because we don't need them just yet. So we'll go back to our build, and I'm going to go here and I'm going to comment out certain dependencies like Spring Security, Spring Boot Security, We're going to get rid of that for now, just for now. Obviously, hopefully we'll have time to bring it back. Okay, so there we go. And I've got Spring Boot started data R2DBC and Spring Boot started RSocket. And I've got a choice of a SQL database driver. I'm going to be using R2DBC. This is the Reactive Relational Database Connectivity Abstraction. It's a way for us to build software that talks to a SQL data store. There are many different implementations supporting many different many different SQL databases, including Oracle, Microsoft SQL Server, H2, Postgres, MariaDB, MySQL, SAP HANA, Google Cloud Spanner, Azure Service, Azure Cosmos DB, and others, right? Anything you can think of that has a SQL interface, there's probably an R2DBC binding for it. That said, I'm happy with my selections for the moment, so let's just go ahead and reload that. And now what I'm going to do is I'm going to build an application that writes data to the database. So I'm going to create an object to map this object to the database. I'll create an integer field here and a string name here. And of course, this is going to be a primary key. And this class needs getters and setters and all that kind of stuff. So I'll use Lombok. Lombok makes short work of creating the getters and the setters and the toString and all that kind of stuff. If you're using any other language, Kotlin or Scala or Groovy or Lisp or literally anything else, you don't have to deal with that. But since we're using Java and we don't have access to the preview feature for records yet, I didn't enable it. We just have to use Lombok. Now I have a repository here, and this repository is going to allow us to read, write, update, delete data. And it has a lot of different methods here. These methods support the obvious data management lifecycle. Things like save all, count, find by ID, delete, etc. All of that is pretty normal. What you may not be familiar with is this type here. Org reactive streams is a jar with 4 interfaces, and these interfaces were defined by the Spring team, by Lightbend, by Netflix, by the Eclipse Foundation, etc. We all got together several years ago and we extracted out common ground definitions for this idea of a thing that has data that will be here eventually, but it's not here right now, and that might be unbounded. Remember, I told you we need a way to describe this kind of unbounded latent data and potentially asynchronous data. That's what this is. This is a publisher, and a publisher works by emitting or broadcasting or publishing data to a subscriber. When the subscriber first connects to the publisher, thing that happens, subscriber is given a subscription. Then we have the onNext method. This is where the any new records, if you have a 1 byte or an object or a date or a Boolean or a record from a database, whatever, each new one gets passed here. So as new records arrive, they're given in the onNext method. If there are any errors, which, again, statistically, there's going to be errors eventually, they also get passed as a method parameter. That is to say, you don't use try catch in the reactive world. You do control flow the same way you do regular data flow, right? And finally, when you're done processing data, when there's no more data to be processed, the onComplete method is called. So we have subscriber, and we have these 4 callback methods. OnSubscribe is, like I said, that's where we get the subscription. And the subscription is what the subscriber uses to request more or less data of the producer. The subscriber says, hey, I need 10 more records. That's it, just 10 more. So the publisher gives it 1, maybe 2, maybe 4, maybe 6, maybe 9, 10, but never anything else until the subscriber asks for more. This is very important because this means that the subscriber can control the rate of consumption, the speed of consumption, right? So this is very, very useful. This means that my service as a thing that is doing something on the internet, I don't want some other service to be able to come over and just drop all this work on me and say, here, figure it out, right? It would overwhelm me and it would cause me to fail. So it's very important that I have the ability to say, no more, I can't right now. This is called back pressure. This is a fancy marketing term, but it basically means flow control. And flow control is not new. If you've ever done any low-level network programming, you've had to think about how TCP does flow control, TCP or UDP. How do you do flow control when one computer sends more data than the other one can handle? That's basic. It's a basic problem that we have to think about at the very low level. Also, at the systems level, we think about flow control, right? Why do we use message buses? Why do you use Apache Kafka, RabbitMQ, or something like that, right? Or MQ series. You do this so that you have something to absorb the extra demand so that the consumer can control the speed at which it consumes the data from the broker. So flow control, obviously a good idea. All we've done is we've made this part of the Java API. So it's now a surface area part of the protocol that every object has. So these are the three sort of everyday types that you're going to deal with all the time: publisher, subscriber, and subscription. Very, very useful, very obvious foundational types. But they're not the only things out there. There's also a fourth type called processor. Now, a processor is a bridge. It's a source and a sink, a subscriber and a publisher, a producer and a consumer, et cetera, et cetera, et cetera. It's a bridge. Now, these four types are foundational. They're very useful, but they're very basic. They're so foundational, however, that they're now in Java 9 and later. So Java util concurrent flow, capital flow, processor, subscription, subscriber, and publisher. These types are one-to-one matches for the ones in the org reactive streams package. And there's even a type here called flow adapters that you can use to adapt from a Java util concurrent flow type to, what does that sound? If you're on the phone, could you please mute yourself, friends? There's a method you can use to adapt from a Java util concurrent flow publisher to a regular reactive streams publisher and vice versa. Okay, so this is very, very convenient, very, very entrenched, easy to adapt, all over the place. The only thing that might distinguish these types is that the reactive streams types work on Java 8, which of course you're not using, right? We had this conversation before. So no Java 8, moving on, you can use these if you want. Now, I have these foundational types, but I think we can agree they're a little Spartan, a little lacking. They don't leave a lot to the imagination. They're very just sort of basic, right? So what I want are specializations to help me support operations on my data streams. And for that, we have Project Reactor, which is the reactive data flow library by the Spring team. It gives us two types. The first of which is mono. A mono is a publisher. It produces 0 or 1 record. Okay, that's it. It's at most 1 record. But it also has a lot of operators. Look at all these operators. I'm scrolling. There you go. Scrolling down to 1,200 lines of code. Lots of stuff. Trust me, you don't want to write this. But these operators make working with monos much easier. They're very, very convenient. Okay, there's that. There's also a Flux, which is a publisher. So both mono and Flux are publishers, but a Flux holds no more than, a Flux holds a potentially unlimited amount of data. So mono, 0 or 1. Flux, it could be 0, 1, 5, 1,000, infinite, whatever, right? It doesn't matter. It's up to you to specify. These are both reactive streams, and they both support lots and lots and lots of operators. Look at that, 2,266 lines of code. Lots of operators. Now, we can use these operators to make short work of writing data to the database. So sample data initializer. And here we're going to create a Spring bean that listens for an event, a Spring event in the application context. We're going to say, when the application starts up, public void ready, we want to write data to the database. So we'll say flux.just A, B, C. And I'm just going to visit each one of these names. New reservation, null name. And what that gives me is I've got a stream of reservations. I've created a reactive stream with just some strings. Then I mapped them into reservations. And I also want to save them. So I'm going to actually visit each record like this one more time. And I'll call reservation repository. I'm going to inject that repository that I just created, the reservation repository. I'll inject a working reference to it. And I'll create a component here, just a regular Spring bean that gets run when the application starts up. And I'll then use that to save records to the data store. Okay, so save R. Now, the thing is, when I call save, it returns a mono of T, where T is a generic type. And what does map do? Well, map accumulates the inner lambda into a container type, right? So map accumulates this into a stream of something. So what I actually have at the moment is a flux of mono of reservation, which I don't want. I want just the flux of reservation. I want to flatten the inner reactive types in the same way that we flatten the curve, right? So here's my updated code. I can replace this here. There you go. Good. And, I've written this pipeline. If I run this program once, I'll get 3 records. If I run it again, I'll get 6, and then 9, and then 12, and so on. So I want to make sure I clean up the database so that we have something consistent. So I'm going to write some data manipulation logic here. I'm going to delete everything, but that returns a mono. Now remember, monos and publishers are asynchronous. They execute on a separate thread. the results may not come back immediately. So we need to make sure that we can order things in a deterministic fashion. So we can use these operators. We can say, okay, once we've deleted everything, then and only then do I want to save this data. And then finally, then and only then, I want to subscribe to all the results like this. So system out, print line, okay? There's my reactive stream pipeline just to save data into the database. Now, keep in mind that I need to talk to a database, so I need to configure that database. I can do that here with Spring R2VC password orders, and I need to configure a username. So username equals orders, and I need to configure a URL. So URL R2DBC Postgres, and of course I'm trusting you not to keep this stuff in your config files. Obviously, with Spring Boot, you can use environment variables or the Spring Cloud Config Server or HashiCorp Vault or Zookeeper's secret configuration management or Console's configuration management or anything, right? Like Azure, Microsoft Azure Secrets. There's lots of abstractions that you can use that all allow Spring to see these configuration sets in the same way. So I've got my application, it's up and running. I've got data in the database. Naturally, I'm going to want to have an HTTP endpoint, right? So I'm going to build a REST controller. And this is fairly straightforward. I'm sure you've all seen something like this, a reservation REST controller. And I'm going to create an endpoint called reservations. And this endpoint is just going to be a stream of all of the reservation data. Okay, so there we go, return. And of course, in order to get that data, I need to talk to the data store. So I'll inject the repository like so. And now I can say return this.reservation repository.find all, and then restart. Now what I've done is I've created just a simple traditional Spring MVC style HTTP endpoint, a controller. Okay. There's also the functional reactive style that you can consider using, and it's really up to you. It's just a matter of taste, and they're both reactive, so it works just fine either way. But this second style I quite like, especially for trivial endpoints like the one that I just built, right? So here I can inject the RR as a collaborating object, and then I can say, given a request, produce a server response where the body is rr.findAll, and like so. So there's my rewritten controller, one line to do all of that, right? It's the same exact endpoint. It's just that one is more concise. So localhost reservations, and voila. Now I've got 3 records hanging out from a JSON endpoint, and I've got 3 records in my SQL database. Who cares, right? Like you could have done this yesterday, right? You don't need reactive APIs for this. I agree with you. I'm not trying to convince you of as much. What I'm trying to convince you of at the moment is that this is not more difficult than what you were doing before. Actually, if you've got some experience using the Java HStreams API, then this should feel very familiar, right? It's not that difficult. And the result is better. It's more resource efficient. It's as we'll see, it's actually more consistent as well. So let's look at the code here. Lines of code is never a good metric, but I don't want anybody to imply that this will create more lines of code. It doesn't. Look, there's my entire HTTP endpoint, right? And I can add as many of these as I want, right? So it's just one extra line to start scaling this up, and I have my configuration in a single place. And then I've got, what is that? 5, 6 lines of code, and then 2, and then whatever this is down here. We're talking 20 lines of code to have an HTTP endpoint that has data access logic and a domain model, right? Trivial though it all is. So not worse than what you did before. Obviously, that code I had to install data into the database, that command line runner here, there you go, that thing, that was for the demo, right? I wrote that. It's a lot of code, but we don't need it. It's just for the demo. So I can leave that out now since we've already got data in the database. Now, that said, it's not bad, right? The amount of code you've had to write is not bad. And actually, I would argue that because you've got one kind of API, life is actually easier now. So imagine you're trying to do Apache Kafka. That's a different API than RabbitMQ, which is a different API than WebSockets, which is a different API than service and events, which is a different API than JMS, which is a different API than just application JSON from an HTTP endpoint. All of these things are just publishers in the reactive world, though. So if you understand how to work with one of them, you can work with all of them. All of the operators apply to all of them. So you have one kind of stuff. And that consistency makes it easier for our brains to keep in our head what's going on. I love that about reactive APIs. I can't imagine having to go back to the world where I have to learn all these different ways of describing to the computer the fact that data is going to be here eventually, right? So many different twisted APIs because none of them give us a good solution. But now we have one. It's called the Reactive Streams API. So, okay, it's consistent. It's not more lines of code. Let's talk about use cases where reactive is not just the same as what we had before, but it's actually better. One common example is whenever you're doing something that is long running, right? It takes a long time. So anything in the old world, in the old sort of non-reactive world, that would take time on a thread is a good candidate if it's IO bound, especially for reactive code, right? So imagine I have an endpoint that returns data over time. I'm going to create a little greetings endpoint here, right? Class greeting request, private string name, okay, and private string message, and voila, okay? Now, at data, at all-args constructor, at no-args constructor, there's my controllers, my entities, my basic types, and I'm going to create an endpoint that returns just a number of records. I'm going to create some sample data here, just as before. I'm going to say return new greetings response, hello request dot get name at instant. Okay, so I'm just introducing time into this code base here. Now, the reason I can do that is because behind the scenes, there's a scheduler, and that scheduler is the thing that moves our work from one thread to another. So here I have a default scheduler, but I don't really need to settle for that. I can actually use any of the other schedulers that I want. And in fact, sometimes you have to do that, right? If, for example, you're doing something that might block a thread, it's very important that you don't block the main scheduler, right? You have to publish this work or subscribe to that work on some other scheduler. The reason is because by default, you only have one thread per core, but each thread is an event loop. So if you block one of the four, let's say you have 4 cores, if you block one of your 4 threads, you're not blocking one user, you're blocking 25% of all your users. We even built a tool to help people figure out where they're inadvertently doing this. It's called block count. It's a Java agent that you can add to the class path. And whenever you do something blocking, like thread.sleep or Fibonacci or whatever, it'll throw an exception. You can see where it's happening, right? So it'll help you find these mistakes and correct it so that you don't end up ruining the scalability of your service. Now, I've got this basic service. Let's build a endpoint. Now, there's a lot of ways for me to communicate data from one service to another. And we saw HTTP, but HTTP has a lot of limitations that make it frustrating for different organizations that are trying to communicate at scale. So obviously HTTP works, okay, obviously, and it's definitely survived at scale for the large web, but for high frequency, low latency kind of communication in a very homogeneous network, they're not the best, right? And so Google, of course, created gRPC, and engineers at Netflix and Facebook created something called RSocket. Now, RSocket goes beyond HTTP 1.0 in particular because it's binary. It has stateful connections, so one side connects to the other, and once they're connected, they stay connected. It supports all the message exchange patterns that you could want. So not just request response like HTTP, but it also supports fire and forget, where you send a message and then forget, don't bother waiting for the acknowledgement of the response. You have, request response, where you send a message in, you get a response back. We have stream, where you send a message in and you get a stream of messages back. And we also have channel, where you can send a stream of messages in and get a stream of messages back, right? So very, very flexible. It's also built to be, indifferent to the kind of encoding. It doesn't matter if you're using XML or JSON or binary thrift or protocol buffers or whatever. It's up to you. This is very different from, for example, gRPC. And of course, it's also built for operations because it was built in these large organizations that have to move at scale. So it has things like metadata in the protocol itself to give you information about the health of the service. And the best part, it's a protocol. So there's clients in lots of different languages. Now, when the engineers at Facebook built a client for Java, they built it on top of Reactor. We've seen Reactor, right? We know what Reactor is. We've been looking at it this entire time. And so we can easily build a greetings controller because the Spring team, realizing that there's this great integration for this protocol, this highly efficient protocol, they built an integration into Spring Framework itself. So all I'm going to do is just use that integration here to produce this response. So private final greetings service. Okay, and it's just going to be a controller, a message. Controller, please. And voila. Okay. 5 minutes. Wow. Okay. Okay. Thanks. So here's my endpoint. Yeah, and I want to run this, but in order to make this work, I need to tell Spring Boot to create to move the application to a particular port. So I'm going to use 8888, and then I'll restart, and I can now talk to this endpoint from my client code, right? So I can use something called RSC. RSC is it's like a curl binding for RSocket. So I can say stream TCP localhost 8888 route is equal to greetings, and the data that I'm going to send in is a name, right? So name and build. Okay, good. So there we go. I'm sending a message in, and I'm getting a stream of results back. Okay, so I'm happy with that. I like my little stream of data there. I don't want to send an infinite stream. I could, but there's no point to that. But notice that what I did there was I was streaming the results, and I was getting back a response every second. In between each result, though, that thread that I was using is freed up. Something else in the system can use it. So now let's go to our client and build a client here to talk to our service. Okay, so client, reactive web, Lombok, come on, RSocket, and that'll do. So we're going to hit generate, and we're going to act as a client to talk to the service that we've just created. So UAO client.zip. Now here's where reactive programming, I think, also really comes into its own, is it gives you a very nice API for dealing with network communication. So let's first talk to our HTTP endpoint, and we can do that using the non-blocking reactive HTTP web client. Okay, so it's called web client, like so. Builder, turn builder.build, and then we can build a bean to inject that builder, right? So application ready event, like so, and this is just going to be an HTTP listener. So it's going to be an object that gets a callback when the application starts up, and we're going to use it to make a call using the bean for the HTTP client, this non-blocking HTTP client. And the way you use the API is pretty straightforward. Look at that. I can just call this endpoint reservations, and the data that comes back is going to be JSON, and I want to turn that JSON into a Java object. So I'm going to do something terrible, something that you should never, ever do, ever, not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. Now, don't do this, and don't tell others that I did do this, okay? So I'll copy and paste my DTOs there. And what I'm going to do is I'm going to just convert that JSON data back into Java objects like so. So reservation.class. And that gives me a reactive stream of reservations. Is this going to work all the time? Of course not, right? Things are going to fail. It's the network, obviously. So hopefully you use DNS load balancing or client-side load balancing with Spring Cloud and the Discovery client. But even there, you might have issues. So you can say, okay, I want to retry. I want to retry 10 times. I want to retry when, and then do a back off, and then add a little bit of time between the back offs. I want to maybe have an error handler. If there's an exception, I want to control how I degrade gracefully, right? That's an option as well. And of course, I can do a timeout if I want. I can specify all that. So there's a lot of really useful things that come out of the box here. And you know what the nice thing about these reactive APIs is that it's very easy to do some very hard things in a very expressive, very elegant fashion. So one example is this pattern called hedging, right? Hedging is where you want to get a result from a service, but you're worried that that service might be garbage collecting or down or slow, whatever, right? You want to make sure you get a response, but if you call a service and that service is busy, you may not have enough time to get the response and meet your SLA. So in hedging, you use a pattern where you launch the same network request to different hosts. Let's say you call host 1, host 2, and host 3, right? And now they're all being launched at the same time. And I want the fastest one to come back and I want to keep that one, and I want to discard the other ones. Well, this is a very easy thing to express using the first operator, right? So host 1, host 2, and host 3, right? That's a very natural thing to express in this way. And of course, that would also apply back pressure to the other 2 slow ones. This reactive stuff becomes even more useful when you consider when you're doing complex scatter gather kind of composition. So imagine, just for example, just as an example here, imagine you have a CRM client, and this client, or better yet, just an interface, and we'll assume there's a definition out there somewhere, but imagine you've got an interface, and this interface gives you a stream of orders, right? These orders have a customer ID and an ID, right? And you've got a stream of customers, and these are 2 different microservices, right? So obviously you have to keep the order data even if the customer deletes their account, right? So there are 2 different microservices, 2 different aggregates, and now I've got a client that's going to allow me to get access to all that data. So get all customers, okay? And then here's another one to get all the orders for a customer, right? So get orders for customer, string customer ID, okay? So a very simple endpoint. Now let's see very quickly here what it looks like to build an endpoint that takes advantage of that. So imagine I have yet another bean here. Actually, just for example, I'll just do it over here since we did the other one over here as well. So imagine I have a pointer to a valid client, okay? And it's not null. Just use your imagination, right? And now I want to say, give me all of the customers, and that gives me a reactive stream of customers. And then for each customer, I want to take the customer and turn it into a aggregate type, a new type. And this is very common in for example, CQRS, where you want to like have a view on the data, right? So customer orders, here we go, and this is a customer and a list of whatever. So this is my materialized view of the data. Okay, there we go. And that aggregate type, obviously a little trivial, but I've got this type, and now I want to be able to instantiate new instances of it based on these 2 network calls, for one for the customer and one for all the orders. And now the problem is this call to the order service is n+1. That's not great, right? Obviously, that's the worst case scenario. But because we're doing things concurrently, it's actually a lot faster than you think, right? Because we have a lot of threads involved, even though it doesn't look like that. So I'm going to visit all the customers, and I'm going to create a zip. I'm going to create a tuple out of it. So the thing on the left is the customer, right? And the thing on the right is the list of orders. So I say CRM client dot get orders for customer, customer dot get ID. What happened there? Customer dot get ID. Okay. ID. Did I not put the? Oh, I didn't. Let's just do dot ID. Okay. Dot ID. So I've got this private. Come on. Ready? Here we go. So I've got by ID. Now I want the actual list. Remember, I want a materialized list. So I'm going to say collect it as a list. That's going to return mono of list of order. So now what do I have? Well, now I have publisher of publisher. Well, obviously, when you see publisher of publisher, somebody forgot to flat map, right? That's easy to fix. And now what do I have? I have a customer orders tuple. I have a tuple that holds 2 values. And so now I want to visit each one of those. I'm going to say map tuple into a new customer order, right? Customer orders. And the tuple has typed values for each of the parameters. So customer is T1 and T2 is the list of orders. And that gives me the aggregate, the sort of the view on the data. And now I can return that from my endpoint. So this is very easy to express in a reactive fashion. So I like reactive APIs, and they make HTTP even simpler, right? Even more reliable. So let's now visit these HTTP responses, subscribe, and I'm just going to print out the results that we get back. Okay. So r system.out print line r.toString. I'm going to say HTTP r. Okay, good stuff. Now that's HTTP, but I did say we're going to use RSocket as well. So let's do that very quickly. We'll build a very quick RSocket endpoint here. And this is going to be using the RSocket client. And we don't call it the RSocket client because RSocket is not client service based. It's either side, once they're connected, can act as both a client and a service. So here, I need to define this RSocket requester, right? We say RSocket requester or responder. And once you're connected, either side at any time can switch, uh, roles. They can become a producer or consumer, right? Very natural. Okay, so there's my RSocket requester. I'm going to use it here. I'll say RSocket requester dot route greetings. I'm going to take the data that comes back, and I want to, I'm going to send data in. That's going to be a new greetings request. Build stuff, okay, and then the results that come back will be greetings response, right? So there we are, greetings response.class, and we're just going to visit that data. Okay, so subscribe gr system out RSocket gr.toString. Good stuff. So there's my my pipeline. Obviously, you could indent it. Let's go ahead and run this code and see what we get. And there, my friends, we've seen a number of different things that you get by using reactive APIs. You've seen how it's more resource efficient. Oh, I think I'm on the wrong port. Connection refused, localhost 8888. Did I? Oh, I didn't finish restarting this one. It got stuck. Sometimes Netty, which is the underlying library, refuses to give up the port, and I have to restart it. I have to kill it and start it again. No big deal. Okay, start. Yep. We're winding down right here. Server port 0. Good. Okay, there's the HTTP results, and there are the RSocket results. So we've seen, my friends, in this brief time that we've had together, we've talked about the motivations for reactive programming. We've talked about its embrace in the Spring ecosystem. We looked at core Spring framework and Spring Boot, Spring Data. We looked at R2DBC, but also keep in mind there are NoSQL options as well for every kind of NoSQL engine out there, Elasticsearch and Cassandra and MongoDB and Redis and Neo4j and whatever, lots of different NoSQL options as well. We also then looked at how to build HTTP endpoints and REST endpoints. We looked at how we looked at the reactor APIs themselves and the operators there. Then we looked at how to build a client, and we looked at HTTP and RSocket. We looked at patterns for building more reliable, more robust microservices and more efficient service orchestration code. And we also looked at, I think, a little bit of details of RSocket. So hopefully, my friends, you've got a sense for just some of the landscape of reactive APIs. But remember, at the end of the day, the goal here is to build better software faster. And so it's no surprise that large organizations like Alibaba, which have the money and the mindset and the need and the smart people, they could build all this stuff themselves, but they instead choose to build on top of the Spring ecosystem. And it's for this reason that all of Alibaba, like I said earlier, is all based on this stuff, including now RSocket. Alibaba, Facebook, the Spring team, and a number of other organizations, Lightbend, we're all part of the initial, we're all part of the founders of the Reactive Foundation, okay? And RSocket is the first project that we donated to that foundation, along with R2DBC. So it's now in the joint care of the community. Thank you, my friends, for your time. I hope you're all healthy, happy, safe. And then if you have questions, you'll feel free to reach out to me at josh@joshlong.com or find me on Twitter at StarbucksMan, STRBUXMAN. Thank you.